Good afternoon, everyone.
Good afternoon, sir. Namaste.
Good afternoon, namaste. Oy, we have a classmate here. The name is a period. Who is this? Kindly update your name so we would know who you are. I'll put you in the waiting room until you rename your Zoom name properly. Okay. So let's now continue. So for this week, what are we to learn? Um, our lesson for this week is actually just easy. Here we go again. All the topics in basic calculus are easy, but actually when the learners are already learning it, they start to struggle in the process. But again, this is just the same as the other topics before in basic calculus. They have patterns, so they are easier to understand. Okay, so let's now start. Thank you. So for this week, we will be learning something about, of course, the integrals. We're still in the integrals. Integrals yielding to inverse trigonometric functions. But before we move on to those integrals, let's first recall what are these inverse trigonometric functions. When we say inverse trigonometric functions, these are the arcsine, arccos, arctangent, arccotangent, arcsecant, or cosecant. In symbols, these are the those symbols, those trigonometric functions with -1 as their exponent. So this is arcsine, this is arccosine, this is arctangent, this is arccotangent, this is arcsecant, and this is cosecant. Ayan. These are integrals with a -1 exponent. I know these are trigonometric functions with -1 exponent. So this is what we will be learning in our process for this week. So for this week, we will be learning integrals yielding to inverse trigonometric functions. And just like what we did in the derivatives, this inverse trigonometric functions, their derivatives will end up with this kind of answers. Sorry. They will end up with this kind of format. So, you all know that when we say integrals, we will be bringing them back to their original function. So if you see functions like, or if you see derivatives like this, of course, we will be ending up with inverse trigonometric functions. Okay, so let's now start the ball rolling. This is the process. So all you have to do is to be familiar with this kind of patterns. So we have here the integral of du over the square root of a squared. A is always a constant and u is always a function. It could be a variable with a squared function. That is, if it is inside a radical, take note that you will end up with arcsine. Okay. Now, if you see given like this for a
The
while,
academic department of Assumpta Technical High School for school year.
okay, going back. So if you encounter a given integral wherein you have the du over a squared plus u squared, again, a is always a constant and u is always a function, then you will end up with arctan. Okay, take note of that. And if you ever encounter an integral like this, du over u times the square root of u squared minus a squared, in this pattern, you will end up with arcsec. Why? Because the derivatives of these inverse trigonometric functions result to this kind of format. Okay, show me a reaction if so far everything is clear. Let me see. We are just in the process of we are still in the process of getting to know these integrals that will end up with inverse trigonometric functions. Okay, so let's now move on with the first example. Let's take a look at this. Here, just like what I told you, all you have to do is to get to know the given and then find which of these three is it related. Kindly take a look at it. Into which pattern is this first given similar? Is it the A, the B, or the C? Kindly type your answer in the chat box. To which pattern is this first given similar? Is it the A, the B, or the C? Kindly type the answer in the chat box. Let me see. See, it's easier to understand. It's easier to identify. It is the same as the letter B pattern. So therefore, we will be focusing on this pattern. We will be focusing on this, which means you will end up with arctan in this process. Okay, so this is just actually very easy. All we have to do is to identify our A and our U. So our A squared, of course, this is still in the A squared format. So our A squared is 4. Can you follow? All you have to do is to get the value of A because in your formula, you will just be using A and not the A squared. So you need to get or extract the square root. So getting the square root of each, you will end up with A is equal to, type the answer in the chat box, please. What is the square root of A squared? I know. What's the square root of 4? Type the answer in the chat box, please. What is the square root of 4? Okay, your classmates are now sending their answers. I need more answers. Very good. The answer is 2. Now that you have that answer, you are in the right track. Okay. After that, all we have to do is to identify our U. So, of course, this is in the U squared form. So our U squared will be equal to X squared. Can you follow? And then get the square root. What's the value of U? What's the value of U, everyone? Type the answer in the chat box. The square root of X squared will be X. Correct. Now, you are about to finish this process. And so, after getting your A and U, you are almost done. Why? Because we just have to move on to this formula. Okay, and take note of this, A should not be equal to 0 or else that's not the right process. Okay, so after that, what will we do here? All we have to do is to substitute using this. So therefore, this will be equal to 1 over, let me change the color to differentiate. Okay, so this will be equal to 1 over A, and A is 2. Just substitute. And then arctan of U is X over A is 2. And then plus C. And you're done. I told you, easy or difficult? Show me a reaction in your chat box, please. Let me see. No, show me a reaction. Chat box, tuloy na sabi ko. Show me a reaction based on how you understood the process. As easy as that. You're done. Just identify your A and U. Finish. Okay, diba? Let's now move on with our next one. Okay, very good. Okay, let me have this now. Let me erase this. Okay, so next is this. Let's have this example. Okay, kindly take a look at our given. The given is the integral of dx over the square root of 9 minus x squared. which of the three patterns is this very much applicable? A, B, or C? Type the answer in the chat box, please. A, B, or C? Let me see. It's letter A, exactly. So therefore, we will be following this pattern and we will end up with arc sign for our result. So same process, let's identify our A and our U. Okay, so we have here, of course, we will start with A squared because our given pattern, our given formula are in the squared format. So A squared is equal to 9. Getting the square root of each, we will have A is equal to, type the answer please. What is the square root of 9? Let me see. Very good. It's 3. Correct. Now, let's move on with U. So we have U squared is equal to, in our given, it's X squared. Remember ha, look at that. Oh. It should always be minus ha. If it's plus, that's different. Okay, so we will have here, get the square root. So U will be equal to, what's the value of U? What's the value of U? It's X. Very good. Oh, now you're almost done. Let's identify the integral of this. So therefore, it's A. We will end up with this answer. Okay, so we will have here arc sine of U is X over A is 3. And don't forget to write plus C. And you're done. Sir, may I ask po, bakit po sila ini-square root? Of course, because if you will look at it, the pattern is in A squared format. So therefore, this 9 is in A squared format. But in your formula, look at your formula, it should be arc sine of U over A. It's not even A squared, it's only A. So therefore, we have to solve for the value of this A. And how will you solve for the value of your A? How will you solve for the value of A if your given is A squared? Sige nga, type the answer in the chat box. Okay, correct. We need to get the square root. So by getting the square root, we will end up with just the value of A, which is, in this case, this will become 3. Okay, similar with U. In our formula, it's U squared. No, in our given, it's U squared. But in the formula, it's just U. So we need to extract the root. Okay? Show me a reaction if everything is clear. Show me a reaction, please. Very good. See, I told you. The lesson is just simple. Okay, let's have another. Okay, let's take this out and let's have another example. What about this? Game. Look at this example. To which pattern is this very much similar? A, B, or C? Type the answer in the chat box, please. Okay, correct. It's letter C. So therefore, we will end up with this answer in the end. Okay. Now, look at this. We just need the A, and the U. So therefore, we need to extract their roots. So same process. We need to get the value of your A and your U. So therefore, let's start with A. So our A squared, always remember A squared is always your constant. And in this case, that is 16. So therefore, what's the value of your A? Type the answer in the chat box, please. What's the value of your A? What's the square root of 16? Very good. The square root of 16 is 4. Okay, you got that. And now you also have here the U squared. In our given, u squared is x squared. So therefore, by getting the square root or extracting its root, what is the value of your u? Type it in the chat box, please. Let me see. It's not C. Okay. The answer is X. Okay. Na-excite lang daw na typo. Okay. So therefore, the value of your U is not C. C is the correct pattern, but the value of your U is X. Okay. And after that, we can now move on with our solution or with our final answer. So let's just substitute. We have here 1 over, what's the answer? 1 over 4 arc sec of, they take note, don't forget the absolute value of u is x over a is 4. Okay? And then plus c. And you're done. I told you. Just that simple. Show me a reaction if the process is clear to you. Very good. Okay. Now, I told you, sabi ko naman sa inyo, dali-dali lang ng given na to eh. Okay, let's have another example. Level up tayo ng konti. But actually, it's not difficult. Same process. So we have here, let me just erase all of this. Oh, ayan na naman. Of course, we should not just settle with a very basic procedure. Dapat nagle-level up tayo. But again, I'm telling you, the process is just the same. Okay, let's have this example. Oh, it's not difficult actually. It's just the same. Nag-iba lang yung number. Okay, so look at this pattern. Ready? The integral of dx over x squared plus 5. Which of the three patterns is this applicable? A, B, or C? Let me see. A, B, or C? Very good. It's B. Same process. Let's identify our A and our B. Let's start with our A. So again, we will start with A squared. If you will look at this, sir, hindi po same yung pattern nila. Because in letter B, nauuna po si A squared kay U. Si number kay U. Pero dito po, nauuna si X squared kay 5. Pareho lang po ba yon? Do you think they are just the same? Show me a reaction if they are just the same. Are they just the same? Yes, very good. They are just the same because remember, look at this. The process is actually plus, and take note that in addition, it's commutative. It's okay to interchange their positions. Just always remember that your A will always be your number and your U will always be your function or the one with variable. Okay? So let's continue. We have here A squared is equal to, in this case, what is our A squared? What is our A squared? Type it in the chat box, please. Type it in the chat box. Don't be afraid. Correct. 5. Sir, paano po pag sa minus naman, like A and C? Pwede po sila magkabaliktad. Yun. In that sense, they should not be, they should not interchange. Their positions should still be the same. Okay? Only in addition, that's applicable. But if the process is subtraction, like in that of A and B, your U should always be after the minus sign. And for letter C, your A squared should always be after the minus sign. Okay? For A and C, the position is very important. But for B, no problem because it's just addition. Okay? Take note of that. So going back, we have here A squared is equal to 5. And then just get the square root. So we have here A is equal to, what's the value of your A? Type it in the chat box, please. Oops, do not use decimal. I suggest do not use decimal, but instead use the radical format. Okay, let me see. Type your answers in the chat box, please. Why am I not asking you to express it in decimal? Simply because the answer will be in fraction form. So if it is in fraction form, there should be no decimal. Remember that. Okay? Sorry for that. So the final answer here is square root of 5. Got it? And now let's identify our u. Our u squared is equal to x squared. And of course, what's the value of u now? Get their square roots. What's the value of u? Type it in the chat box. Okay, the answer is x. That's it. And now, all we have to do is to substitute in our given. So we have 1 over a is the square root of 5. Can you follow? And then next is arctan of u, which is x, over the square root of 5. And then just add plus c. And you're done. Oh, di ba? I told you it's not difficult. Show me a reaction if that's clear. Okay, very good. Oh, di ba? This is what I'm telling you. It's not actually difficult. Okay, let's continue. Ready now for the next example? Sir, same lang po if dx du po. Oh, wait lang. Chill ka lang. Meron pa tayong next examples. Okay? Excited naman kayo eh. Okay. Now, since your classmate already asked of the DU, hindi pala scam. Yeah. For now, it's not scam. I told you. Okay. So since your classmate is now so excited, what about if same lang po ba yung dx and du po? Oh. Yes, actually, dx and du are just the same. The du is in general format and the dx is already in the x format, the function format. Ito. Let me just show it with you so that you will see that they are just the same. This is what your classmate is asking. Sir, pareho lang po ba yung dx sa du? Here, this is what your classmate is telling me. Actually, this is the original one. This is the original given, or this is the original formula for the integrals yielding to inverse trigonometric functions. So we have here, same. You have here the x squared, yeah, a squared, which will turn into a, your x squared, which will turn into x, a squared, x squared, and then same process actually. They are just the same. However, and of course, du and dx are just the same. But why do we need to express it still in du? Why? Simply because our next examples will tell us or give us the answer to that why. Okay? Shall we? By the way, this is just less than a minute. This will already end. Please join again in the same link for the continuation. Okay? Thank you so much.